So today we're going to continue our study of solving equations. These are one-step equations. And today we're going to add in rational coefficients. If you need to know to look it up, this is chapter 6, lesson 3. Let's start by going over some vocabulary and making sure you're clear what all these big fancy math words really mean. All right, so I've got 3 main words here that I want to talk about. A rational number is a number that can be written as a fraction. For the most part, it's negatives and positives and fractions and decimals. It's most of the numbers you know how to deal with. There are a few that you can work with now so far in your studies of math that are not rational numbers, but most of the numbers that you know how to deal with fall into the rational number category. How about a coefficient? We've talked about this several times this year. It's the number in front of the variable. And I have 2 examples here for you. So if I have 4j, the coefficient is the 4. It's the number that's multiplied by the variable. If I have negative 5 and 6/10 x, negative 5.6x, the coefficient is the negative 5.6. It's the number multiplied by the variable. And this, of course, is an example of a rational number. So is this, but we don't think much of it because we've talked about the counting numbers and integers for a long time. Okay, let's also review reciprocal. I know this is a word that you've heard in the past. It's the flip of a fraction. Some cutesy math teacher somewhere called it the fliprical, and it stuck, but it's not a math term. So if I had the fraction 3/4, the reciprocal would be 4/3. The numerator and denominator switch places. Notice that I did not put an equal sign in the middle. These are related, but they are not equal. This is less than 1. This is more than 1. Fun fact, if you multiply the numerator and the denominator of the number and the reciprocal, you should get 1. Mind blown, right? 3 times 4 is 12. 4 times 3 is 12. 12/12 is 1. If numbers are reciprocals of each other, that will always work. Let's look at a whole number real quick. We don't have a denominator here, at least not written. So we know that that would be the 1. If they switch places, the reciprocal is 1/7. Again, not an equal sign in the middle. And if I was to multiply these, 7 times 1 is 7. 1 times 7 is 7. 7/7 is 1. So those are indeed reciprocals of each other. Okay, as far as solving the equation, all of our steps still apply. We're going to split it. What are we looking for? What's attached? How is it attached? How do I undo? Undo to both sides and get your answer. That doesn't change. There might be a couple other little things we have to be careful of because of the type of number that's presented. So let's get the decimal out of the way here. This is an easy one. Solve 16n. I'm sorry, this is not correct. Solve 16 equals 0.25n. There is no variable with the 16. It's just a plain 16. Okay, so we're going to split it at the equal. We're looking for n. The 25/100ths is attached by multiplication. So we're going to divide. This is where I get lazy and don't put the 0. Just put the 0.25. So we've got 25/100ths divided by 25/100ths. They will cancel to 1. I'm left with n. Then I'm going to do 16 divided by 25/100ths. I know most of us are going to reach for a calculator. I'm going to do the same thing in a second, but I wanted to refresh your memory on how to set this up. Okay, 16 goes inside because it's the numerator. 25/100ths goes outside because it's the denominator. I don't really want to divide by a decimal, so I'll multiply by 100 or move it twice. If I do it to the outside, I have to do it to the inside. So now it's like saying 1600 divided by 25. Or think of it as $16 divided by 25 cents. How many quarters does it take to make $16? 16 divided by 0.25 equals, I got 64. Well, and that makes sense because it takes 4 quarters to make $1. So if I have lots of dollars, I'm going to have lots of quarters. My number got bigger. And then you should check it. Even if it's just in your head, go back and say, is 0.25 or 1/4 times 64 equal to 16? Calculator's fine with me. All right. The decimals, I think, are pretty straightforward because it's just a simple division. Even if there was a negative sign involved, it's still fairly straightforward. All right. Let's talk about fractions as your coefficient. This is where the reciprocal comes in. All right. Same steps for equations. Split it. I'm looking for x. The 3/4 is attached by multiplication. So I'm going to divide by 3/4. And if you write it like that, you are perfectly correct. But when you get over here, you have just created a nightmare for yourself. Ew, ew, ew. That's called a complex fraction. Fractions within fractions, ew, ew, ew. There's an easier way. Let me rewrite it. This is not wrong, by the way. This just hurts your head. I'm going to show you a way that's a little bit kinder to your noggin. All right, same thing. I'm still going to divide or split it. We're still going to divide by 3/4. But instead of dividing, mathematically, if I multiply by the reciprocal, that still gives me 1 over there. Isn't that what I want? I want x to have a 1 in front of it. So dividing by the number or multiplying by the reciprocal accomplish the same thing. So if over here I multiply by 4/3, over here I'll multiply by 4/3. This is going to be so much easier. 4 and 4 cancel, 3 and 3 cancel. Yay, I get my 1x. That's what I wanted. On the other side, you've got 2 choices. You can simplify or check to see if you can simplify to start and then multiply. Or you can multiply and then check to see if you can simplify. Either way, you should get the same answer. I personally want to simplify in the beginning just because I like smaller numbers. So let's see. I have a 4 that I can divide by 4 and a 20 that I can divide by 4. I'm left with 1 and 5. Here I'll divide by 3 and divide by 3. These numbers are so much easier. 1 times 4 is 4. 1 times 5 is 5. I can't simplify any further. There's my answer. Now, for those of you who are resistant to the check step, again, this will make you a believer. Take your original, put in what you think the answer is, right? 3/4 times x, I think x is 4/5, and see if it gives you your answer. Easy check here. 3 times 4 is 12. 4 times 5 is 20. We're good. Okay, I have 2 more for you. One not so bad and one that's yeek. So this one's a little bit unique in that we have a negative and we have a whole number on the other side. Same steps. Split it. What am I looking for? What's attached? How is it attached? How do I undo? So this 7/9 is attached by multiplication. I'm going to divide, but I don't like dividing by fractions. So instead, I'm going to multiply by the reciprocal. 7 and 9 switch places. I will keep the negative with it. It doesn't matter where the negative goes. Remember, you can have the negative on the top, you can have the negative in the middle, or you can have the negative on the bottom. As long as there's a single sign, it doesn't change the value. So it started with the 7. I just kept it up top. I could have moved it with the 7. It doesn't make a difference. Okay? When I get to the other side, I'm still going to multiply by a -9/7. This little guy needs a denominator. On the left, negative times negative is a positive. That's what I want. 9 and 9, 7 and 7. Leaves me with plain D. On the other side, I see a single sign. Let me take care of that to begin. 5 times 9 is 45. 1 times 7 is 7. You can leave it in improper form. I'd actually prefer you to leave it in improper form. If you insist, you can switch it to mixed number, but it's an extra step. It's an extra chance to make a mistake. Not worth it. Okay? When you go to check, you take your original, you multiply by what you think the answer is, and you check to see if it works out. So sign-wise, negative times negative is positive. We're good there. I can cancel the 7s. 45 times 1 is 45. 9 times 1 is 9. Is 45 ninths equal to 5? Yeah, we're good. That's the correct answer. I have one more for you. You actually won't see one this challenging in the book. You'll see some mixed numbers, which is why I'm pulling this out. But the mixed numbers are usually on the side that's by itself, the constant side. The mixed numbers for what we're doing in this lesson are not usually as the coefficients. But while we're studying this, you might as well see all the different variations that could possibly happen. All right, so let's tackle this. We still split it. What are we looking for? What's attached? How is it attached? How do I undo? The negative 2.5 is attached by multiplication, so I'm going to divide. But if I didn't like dividing by fractions, I certainly don't like dividing by mixed numbers. So let's get these out of mixed number form. We'll switch them to improper, and then we'll come back and tackle the equation stuff. Okay, so my negative sign is going to stay. We do denominator times whole number, so 2 times 2, and then add the numerator. 2 times 2 is 4, plus 1 is 5. Keep the denominator, and keep the variable. So I haven't really done any calculations yet. I'm just switching forms. All right, let's do it over here. Numerator times denominator times whole number. Sorry about that. Add the numerator. 20 times 2 is 40. 40 plus 1 is 41. Keep the denominator. Now we can get rid of this coefficient. We said it was multiplication, so I'm going to divide. I'm not a big fan of dividing, so I'll multiply by the reciprocal. Keep the sign. And what you do to one side, you do to the other. Be picky that your signs don't mesh with keep them all straight. All right, so here we go. 2 and 2, top and bottom. 5 and 5, top and bottom. That's 1. 2 negatives is a positive, so I get W. Yay, that's what I wanted. On the other side, one sign, let me take care of that to start. I do see a 2 and a 2 that I can cancel, which leaves me with 1 and 1. Well, that makes it easy. 41 times 1 is 41. 1 times 5 is 5. Done. If you insist making it negative 8 1/5, fine. You don't have to. Okay? Then let's go back to the original. Now, you could go to here. If you're a purist, you'd go all the way back up here. Ew, that gets ugly. I'm going to the brown step that I wrote. So negative 5 over 2 times negative 41 over 5. Does that equal positive 41 over 2? Lots of copying in this. You got to be real careful that you don't miss something. All right, so let's double check here. We've got negative times negative is positive. That's a good thing. I can do the 5 and the 5, and that goes to 1 and 1. So now 1 times 41 is 41. 2 times 1 is 2. We are golden. All right, change. Let's spell that right. Change mixed numbers to improper. Whenever you're calculating, that's just kind of a general thing that happens a lot when you have to calculate with mixed numbers. Often you will change them to improper fractions.